All right, question number 6. We're cruising along now. Again, we're asked to solve the equation by completing the square. So you'll notice that these first several questions on the practice test we're solving equations just using different methods. And in this case, we're asked to complete the square, and we're given the equation x squared equals 7 minus 8x. And the first thing we want to do is notice that we have x's on both the left-hand side and the right-hand side of our equal sign. Let's go ahead and get the x's on one side while keeping our 7, the constant, on the other. And probably the easiest way to do that is to go ahead and add 8x to both sides. And so when we do that, we end up with x squared plus 8x equals 7. And so now we're ready to complete the square. We have our x's on the left, we have our constant on the right, and one thing I like to do, you don't have to do this, but before I actually begin to complete the square, I like to rewrite the equation, the quadratic here, one final time, except I like to add what I call blanks for right now. So we're going to end up with x squared plus 8x plus blank equals 7 plus blank, some number, right? Because remember, when we complete the square, the number that we use to complete the square has to be added to both sides. And this little model here just helps me to remember to do that, because if we're dealing with an equation, something that has an equal sign, whatever we do to the left-hand side, we have to also do to the right-hand side. You don't have to do this, but if it helps you, then great. All right, so let's go ahead and actually complete the square. Well, we know that when we complete the square, we have to take half our middle term. So in this case, we have 8, and half of 8 is 4. And whatever half that middle term is, we're then going to square that number. And so if half of 8 is 4, we then square the number 4, and 4 squared gives us 16. So this is the number that we are going to be adding to both sides, and that's where these little blank lines come in. So whatever we do to one side, whatever we add to one side, we have to add to the other. All right, let's go ahead now and clean this up a little bit. When you complete the square like we did here on the left, what you've done is you've now created what's called a perfect square trinomial. Notice that we have 3 terms on the left, right? We started with 2, x squared plus 8. By completing the square, we end up with 3. So we now have a perfect square trinomial. And we can write the left-hand side as a squared binomial, meaning what we can do is go ahead and open a set of parentheses, and then whatever variable letter you're working with will be the first term. So in this case, we're dealing with x's, so we'll write x. Whatever the middle sign is will come down, so plus. And then again, whatever half the middle term is will be the final term in our binomial. So again, half of 8 is 4. Close your parentheses and then square it. So the perfect square trinomial x squared plus 8x plus 16 becomes the squared binomial x plus 4, that quantity squared, and now equals the right-hand side, which is going to be 23. Well, now this looks very similar to what we were dealing with earlier in this practice test, doesn't it? Where we have to solve for x, and in order to do that, we're going to have to use the square root property. So we know that we have to take the square root of both sides, but don't forget, when you create your own square root, you have to remember to add the plus and minus notation. All right, so here on the left-hand side, when we take the square root, this square root cancels the second power here, and we're left with just the quantity x plus 4. And then on the right, we're going to end up with plus and minus radical 23. Again, if you could break down this radical 23, maybe it was a perfect square, you definitely want to go ahead and take the perfect square out, or if you could break it into something that could come out and then something that stays. Sometimes we call that good stuff, bad stuff. Then you want to go ahead and do that. But with radical 23, it's certainly not a perfect square, so we can't simplify this. And there's no perfect square inside of 23 that we can break this radical down into a simplified version. So we just have to leave it just as is. And then if we're going to solve for x, then we want to go ahead and subtract 4 from both sides. And this is then going to leave us with x equals -4 plus and minus radical 23. And there we have it, our solution for number 6.